Hello. I welcome you all to this another interesting screencast. The problem reads locate the centroid X bar of the area as well as Y bar. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have been asked to locate the centroid, and before we proceed, let's briefly talk about what centroids are. So what is centroid? Centroid is basically the geometric center. So this can be the geometric center of a line. It can be a geometric center of an area. It can be a geometric center of a volume, right? So we have what is called centroid of a line, centroid of an area, centroid of an area, centroid of a volume. All right. And when density is uniform in a given body, given material, then you expect centroid to coincide. You expect centroid to coincide with the center of mass. And when the gravitational field is uniform, you expect centroid to coincide with the center of gravity. All right. So I think this is about it. Brief summary of what centroids are. Let's dive into the problem now. What we have two curves. We have one curve that goes like this, and then we have another curve, right? So we are subtracting one area from another area, right? So this is what is happening. So if we were to look at one curve, just one curve, this curve alone, okay, and then let's say we look at the area along the x-axis from 0 to 1. So we are looking at this area, right? Is that so? Great. And then if we looked at another curve in green, which is this one there, and also let's shade this area. We shade this area like this. All right. So when we subtract this curve on top, I'm going to call YA minus YB. Then you'll have this area in blue and red, right? Is that fine? So this area in blue is this YA minus YB, which is equal to x2 over 3 minus x3 over 2, right? So this is more or less a composite area, right? Where we have a difference of two areas. Okay, great. And again, the other thing is, when you look at these particular curves, there is some symmetry, right? If we are to draw a line here, like so, look at this line. Okay, something like that. Look at this. This line is defined by the equation. This line in between here is defined by the equation y is equal to what? Y is equal to what? Y is equal to, I've gotten you, x, of course. See? Y is equal to x. The gradient is 1. The gradient is 1. So, one curve, one curve is the mirror of the other, right? Great. So, there is symmetry along that axis I've just drawn. This inclined axis, there's symmetry on this axis here, on this axis, this inclined axis. Great. All right. So let's dive into the work. So what do we do here? We have been asked to find the centroid x bar and y bar. So as usual, we need to cut a small strip. So let's cut a small strip. We start with this. And maybe we may continue with the same one. This one I think is much easier. You can check the other one. I'll not check the other one, but this is going to be easier. All right. You can check the other one as well. I'm sure it will not be, yeah, you can check the other one, but I'll go with this one. All right. So we have this strip, and then this strip has thickness dx. What else? And then we said this height here, this height, what is this height? This height, if we record this below here is my YA, and then this one as my YB, then this one becomes what? Guess? Becomes what? This height becomes what? What are you saying? I've gotten you. This becomes a YA minus YB, right? Great stuff. So now, let me wrap this because I want to use this distance here. Let me take it down somewhere there. Okay, I go down somewhere there. I put it here. All right. Okay. And then we'll need to define this distance here. I mean this height here. So this height here is going to be equal to this height from there to there. It's going to be equal to, what do you think? I think I use black. I just use black. This height here, I'll take it to the other side there. This height, what do you think about this height? This height is just going to be equal to what? To y. Great. And then what is our x centroid axis in the x direction for this small strip? It is going to be equal to x curled is equal to x. And what's our centroidal axis in the y direction? It's going to be equal to the mid span of that, which is going to be equal to, what is this? This is going to be equal to y curled is equal to, okay, this is y curled is equal to, y curled is equal to what? It's equal to y plus ya minus yb divided by 2. Great. Okay. Any other information we need on here? I mean on this figure? Wow, let's define the small area we are calling dA. So our dA in there is going to be equal to, what is our dimension for this small strip? Okay, can think of it as a small rectangle. So this is YA minus YB times what? What's the thickness? Dx. Great stuff. I think if we are done with defining everything, what we need to do now is to start working. Let's start with x bar. So our x bar is going to be equal to integral from 0 to 1 x squared dA divided by 0 to 1 dA, which is the total area. So we have x bar equal to integral from 0 to 1 x squared dA. What is our dA? Our dA is YA minus YB dx divided by integral from 0 to 1 YA minus YB dx. Then our x bar is going to be equal to integral our x squared. What did we say our x squared is? This x squared is just x, so you can replace x there, 0 to 1. And then what is our YA? Our YA is what? What is our YA? Our YA is x to the power 2 over 3 minus x to the power 3 over 2 dx divided by integral from 0 to 1 x2 to 3 minus x3 to 2 dx. And then when we multiply the top there, it gives us, when we do the multiplication top there, it will give us x to the power 5 over 3 minus x to the power 5 over 2 dx. Then at the bottom it just remains the way it is. Okay, and then we do the integration. If we did the integration, we are going to have the following. We'll have the following. So this one becomes x to the power 8 divided by 3 minus this one divided by 8 over 3, then minus x to the power 7 over 2 divided by 7 over 2. Then everything, of course, we are integrating from 0 to 1. Then below there also we have x to the power 5 over 3, right, divided by 5 over 3 minus x to the power 5 over 2 divided by 5 over 2. Integration constant from 0 to 1. Alright, and once we've done so, we will evaluate that. We're going to have the following. X bar therefore is going to be equal to, if we've evaluated this, then we'll have a 3 divided by 8 minus a 2 divided by 7, okay, divided by 3 divided by 5, okay, minus 2 divided by 2 divided by 5. Okay, so if we evaluated this further, then we can multiply this side by 8 this side by 8, this side by 7, this side by 7, and then we have eventually we're going to have the following. We have eventually a 21 minus 16 divided by 56, right? 56 divided by 1 divided by 5, and therefore our x bar finally is going to be equal to 21. 21 minus 16 is what? That's a 5, and then by this 5 there, so we can multiply 5 this side, we multiply 5 this side, we multiply 5 that side, then we are going to have a 25 finally divided by 56, and this is our final solution. Okay, this is our final solution. So let me write it here because I'll need some space. So I have my x bar, which is equal to 25 divided by 56. Okay, then I also need to indicate my total area because I don't want to recalculate this. My total area is just 1 over 5. This one here, this is my total area, right? It is just 1 over 5. Okay, let's find y bar. Y bar is going to be equal to integral from 0 to 1 y cubed dA divided by integral from 0 to 1 dA. Okay, so what is our y cubed? Y cubed we said is equal to a y plus ya minus yb divided by 2, right? But what is this y? This one here. This y here, when you look at this, okay, this y, it is being governed by this lower k, right? You accept? Okay, sure. And therefore this y is going to be equal to yb. Okay, so our y cubed is going to be equal to yb plus ya minus yb divided by 2, and if we simplify this we can divide both sides by 2, then this gives us a yb plus ya divided by 2, and therefore this gives us just x to the power 3 over 2 plus x to the power 2 over 3 divided by 2. Alright. Okay, and our dA, we said our dA also is equal to our dA is equal to ya minus yb dx, and therefore this is going to be equal to x to the power 2 over 3 minus x to the power 3 over 2 dx. Okay, and therefore our y bar equal to, we start replacing from 0 to 1. Our y bar, what is our y bar? This one here. What's our y bar? We've already found it. Is this one here. Okay, it is this one here. Y curled bar. Okay, this is curled. It's curled. This is the centroid position for the strip. Okay, curled. So that becomes x to the power 3 over 2 plus x to the power 2 over 3, and then we factor out the 2 outside there, and then we have dx, which is x to the power 2 over 3 minus x 3 over 2 and dx divided by 1 over 5. What do you think of this part here? This part, look at it properly. It reminds you of what? Difference of two squares. Great. So let's write that. Therefore, our y bar is going to be equal to 1 over 2 integral from 0 to 1. Difference of two squares for that, what does it give us? Look at that. What will be the value of that? Of course, if you worked out this as just a difference of two squares, so we are saying, maybe let me write it. So we are saying x 3 over 2, I'll rearrange it. This one I'll rearrange it. So I'll write it as x 2 over 3 plus x 3 over 2, and then x 2 over 3 minus x 3 over 2. This is a difference of two squares. So if you wrote this one is also equal to this one is equal to x to the power 4 over 3. Okay, when this guy multiplies with this, and then a minus this guy goes with this guy, minus, what do you get when you do so? This becomes x to the power what? To the power 3. Alright, so replace that there. You just go like y bar is equal to 1 over 2 integral 0 to 1. Then we have x to the power 4 over 3 minus x to the power 3 dx divided by 1 over 5. Okay, is that fine? Then if you did the integration finally, what do you have? We are going to have 1 over 2 like so. Then this one becomes x to the power 7 divided by 3, then 7 over 3 minus x to the power 4 divided by 4, integrating from 0 to 1 divided by 1 over 5, and therefore y is going to be equal to 1 over 2, this becomes 3 over 7, okay, minus 1 over 4, and then divided by 1 over 5. Then this one can multiply there. I want to factor it out. You can multiply by 4, this side by 4, then this side by 7, this side by 7. Then we have a 12 minus, what do we have? We have a 12 minus 7, which becomes a 5. 5 times 1 over 2 divided by 1 over 5 times 5 times here we have 5 divided by 7 by 4, which is 28, right? Then we multiply by 5 there, then we multiply by 1 over 2, and then by 5 is 1 over 2 there. So 5 and 5 goes, right? And finally, the final solution, we have y bar is equal to 25 divided by 28 by 2, which is a 56. Right, so the summary of the solution, we have x bar equal to 25 divided by 56 meters, and y bar also equal to 25 divided by 56 meters. So this is about it. And I hope the video was helpful. If it was, give me a thumbs up, like my video, subscribe to my channel, give me a thumbs up, continue sharing my channel. Bye bye, and see you in my next screencast.